Hey guys, in this video, I'm going to be going through all the formulas which you have to know before you go into your exams, because remember that physics is largely maths based, so you are going to expect a huge number of calculations, and there's no way that you could do well on this type of questions if you haven't bothered to learn all the equations. So let's get started. The first one we've got here is under the first chapter of motion, whereby speed is the distance traveled over the time taken, or in another word, it's the velocity. You can also write them as v equals to d over t. Remember that the distance always is in meter and time is in second. So meters divided by second will give us the unit for velocity, which is m/s. Units are extremely important in physics, and remember the SI unit for each quantity. For distance, it's always in meter and time in seconds. Next, acceleration is the change in velocity per unit time. So to find the change of velocity, we're going to take the final velocity minus the initial velocity over time. Acceleration means an object's speed is increasing over time. So the final velocity will always be higher than its initial velocity. If the question gives you information such as object at rest, this means that the initial velocity here would be at 0 meters per second. And the unit for acceleration is meters per second over second, giving us meters per second squared. Sometimes you may be asked to calculate speed from a distance time graph, and you can get the speed by taking 2 points of the graph and then use the formula of gradient to get the speed. And if you're given a speed time graph, the gradient of this graph will represent its acceleration. And to get the distance traveled for the object, you can find the area below the graph. And if your speed time graph looks something like this, then finding the gradient would be a little bit more complicated, whereby you're going to draw a tangent for the time of acceleration they're looking for, and then repeat the same thing. Get 2 points furthest from each other and use the formula of gradient to obtain the acceleration. Next, under mass and weight, you must know the difference of mass and weight. Mass is the measure of quantity of matter, whereas weight is going to be the mass multiplied by its gravity. So W equals to m times g, and the value of g if on Earth is always given, which is 9.8. Make sure that mass is in kilogram and the unit for weight will be in newtons. Next, density. Density is the mass per unit volume. So the formula is m over v. If the mass is in kilogram and the unit is in meter cube, then the unit for density would be kilogram per meter cube. Questions regarding density are usually quite straightforward, and usually these types of questions are combined with chapter 2 for specific heat capacity, where they will give you the volume and density, and they'll ask you to find the mass to be substituted into the formula of energy. So to do that, mass would be density times volume. Next, under the subtopic of forces, you're going to have to learn a lot of formulas. One of them is based on the principle of Hooke's law, whereby the extension of a spring is directly proportional to the force applied, provided that its limit of proportionality is not exceeded. Make sure you know the principle of Hooke's law, because you could be asked and this would give you 2 marks. And the formula for this is F equals to K times X. The unit for force is Newton, and extension of spring could be in centimeters or meters depending on the question. So the weight applied here would be your force. Make sure it is in Newton. If they have given you the mass in kilogram, then make sure to convert it into Newton by multiplying by 9.8. And depending on how much the spring has extended, that would be the value of X. Alright, next you've got the Newton 3 laws. I'll let you guys read this by yourself. However, from Newton's second law, you will learn another formula which is very popular. Resultant force equals to mass times acceleration. F equals to ma. The unit of acceleration is meters per second square, mass is in kilogram, and the force will be in newtons. Moving on, to calculate moment, you're going to take the force times distance. And the distance has to be perpendicular from the pivot point. And it will help in your calculation if you understood that there is no resultant force and no resultant moment when the object is in equilibrium. This means that the anti-clockwise moment and the clockwise moment is equal to each other when they are in equilibrium. The unit of force is in newtons and distance is in meters. So that gives us the unit for moment, Newton meters. Next up, for momentum, which is also a very popular type of question, where momentum is the mass times velocity. The mass of the object is in kilogram and velocity is meters second. This gives the unit for momentum, kg m/s. This type of question can be really tricky because momentum is a vector quantity, that means it comes with a direction. So in case you're asked to find the momentum of this dummy, you're just going to take the mass of this dummy and multiply it with the speed that it is moving, and that's it, you're going to get the answer. However, if you're asked to calculate the change of momentum, then you're going to do the mass times its final velocity minus the mass times its initial velocity. So the initial velocity is moving in this direction, this will be in positive, and when the ball bounces back, it's going to be in the opposite direction, so your final velocity will now be in a negative value. Always pay attention to these types of questions. This is going to make a huge difference to your answer, so make sure you do not forget the symbols. And these types of question will always continue to ask you on impulse, whereby impulse is equal to the change of momentum. And impulse is the force times time, so force times time could also be the change of momentum. So once you have gotten your change in momentum, it can be used to get the impulse, and you will be able to obtain your time or force depending on what the question needs. Next, under work, energy, and power. Power is known as the work done or energy transferred per unit time. So here's the formula. Power equals to work done over time taken. Work done is measured in joules and time in seconds. So the power will be joules per second, or you can write watts, which is W. If you're not given with the work done, you could instead use the change of energy per unit time. Sometimes the question will ask you to calculate the energy, so you can just rearrange it by multiplying power with time. Just make sure that your time is always converted into seconds. And the unit for energy is in joules. There are two types of energy that you have to pay attention to. The first one is kinetic energy, which is half mv square. And the second one is potential energy, which is mass times gravity times h. So in this question, if they ask you to find the h, you can assume that the GPE is equal to the kinetic energy. You could easily cancel out the m on both sides and then use the velocity of the waterfall, let's say 100 meters per second, and then the value of g is always 9.8, and you can obtain your h easily. And next off, you've got efficiency, whereby depending on the question, if they want you to find the efficiency of energy or power, it's always going to be output over the input and multiply it by 100. Efficiency have no unit, so you're just going to leave your answer as percentage. And the last topic for this chapter is to calculate pressure, whereby it is force over area. Force is in Newton, and when you're asked to calculate area, make sure it is in meters square. This will give the unit of pressure, which is N/m square. And if the question is related to pressure in liquid, then the formula will be H rho G. G depends on the density of liquid that is being tested in the question, and then G is a fixed value of 9.h, and the height here is depending on the depth of the object from the surface level. So you can just put in all the values and get your answer in Newton/meter square, or you can leave your answers in Pascal. Alright, moving on to chapter 2. This chapter doesn't have much formulas or calculations involved. Make sure you know what is absolute zero, which is the lowest temperature at 273 degrees Celsius. You might be asked to convert Kelvin into degrees Celsius, and you can do this by adding 273. And according to Boyle's law, P1V1 is equal to P2V2. For instance, if you have been given pressures on before and after, and if you are asked to calculate another volume, then this is when you would apply Boyle's law, given that the temperature is constant. And the most popular formula or calculation related to this chapter is regarding the specific heat capacity. Anytime you see specific heat capacity, you can immediately write down the formula of mc theta. Theta is the change of temperature, C is the specific heat capacity, mass is always given in kilograms or gram. So make sure you always convert it into kilograms, and the energy will be in joule. Sometimes they will not give you the mass because the density and volume is provided. So as mentioned previously, you can use the formula of density, rearrange it to get the mass for this formula. And moving on to chapter 3, under the general properties of wave, which is the number of waves passing per second, which can be calculated by 1 over time. And time here would be in seconds, and the unit for frequency is in hertz, Hz. And next, if you're asked to calculate the speed of a wave, you can use the frequency times lambda. Lambda here is the wavelength, and wavelength will be in meters. Wavelength can be calculated from one peak to another. This distance would represent the lambda. Next, under the subtopic of light, you can be asked to calculate the refractive index, which is the speed in air over the speed in medium, or sine theta, which is the angle in air over the angle in medium. So this would be the incidence angle, and this here would be the refracted angle. Sometimes they might trick you by giving you the angle over here. So be sure to get the incidence angle. You're going to do 90 minus the angle which is given, because you always want to find the angle between the normal and the line, the normal and the reflected line, this angle. And another formula to find refractive index is 1 over sine C. C here represents the critical angle. So let's say when you're asked to calculate critical angle, it would be refractive index 1.5, 1 over sine C. To get C, you're going to do shift sine 1 over 1.5. Don't forget, when bringing shift to the other side, it's going to be sin to the power -1. Next subtopic on sound, you will learn about echoes, which are a reflection of sound wave. The formula related to this is the same as the formula of speed, which is distance traveled over time taken. However, questions related to echoes can be a little bit tricky. So let's look at an example. It's mentioned here that ultrasound is used to detect the depth of the ocean. So let's say this is the bottom of the ocean. The ultrasound pulses are emitted from the transducer on a boat, and some of the pulses are reflected by the bottom of the ocean back, like this. So the shortest time between the sound waves being emitted and detected, this takes 0.52 seconds. That means going down, hitting the bottom and coming back up takes 0.52 seconds. And the speed of this wave is moving at 1.5 kilometers per second, and you're asked to calculate the distance. So we can rearrange this to get speed times time. So the speed is 1.5 and the time is 0.52, giving us 0.78 kilometers. So remember, the distance traveled is going down to the bottom and then coming back up. So the total distance traveled is 0.78 kilometers. But you're asked to find the distance between the boat and the ocean floor, which is the height. Therefore, you're going to take this value and divide it by 2, which is 0.36 kilometers or 360 meters. Just remember that when questions are related to echoes, you usually have to divide your distance by 2, because the distance goes one way and come back as an echo in the opposite direction. Next, moving on to chapter 4. Chapter 4 is probably one of the most difficult chapter in your syllabus. There are as many calculations as there are theoretical questions. So if you don't understand much on the theory, at least try to focus on the formulas and the calculations, so you get to score a maximum mark on these types of questions. Firstly, you've got current, which can be calculated by charge over time. The unit for charge is coulomb and the unit for time is in seconds. And the symbol of current is I and the unit is A, which stands for ampere. Next, you've got electromotive force. Make sure you know what is the difference between electromotive force and potential difference. They are both represented by the symbol V. Electromotive force is the voltage across the batteries, like this, and for potential difference is more for the voltage across a component. So EMF can be calculated by the work done over charge. Work done is in watts, W, and Q is in coulomb. And the unit for EMF and potential difference both are in voltage. Next up, for resistance, you should know that resistance is directly proportional to length but inversely proportional to area. This means that the longer the length, the higher the resistance. If the length here was 5 meter and this is 10 meter, and resistance given here is 2 ohms, then automatically you should know that the resistance here is 4 ohm. Since it is directly proportional, it will increase at the similar ratio. However, resistance on the other hand is inversely proportional to the cross-sectional area. The bigger the cross-sectional area, the lower the resistance. Let's say this wire has a radius of 5 centimeter, then the cross-sectional area would be 25 pi. And if they mention that the resistance is 2 ohm, let's see how it affects the resistance if the wire was double sized, meaning the radius will now be 10 and the cross-sectional area becomes 100 pi instead. So this increases by 4 and your resistance will decrease by 4. So this new resistance now will decrease to be 0.5 ohms. And if resistance were asked to calculate from a circuit, then you should know that according to Ohm's law, which states V equals to I times R, if we rearrange this, we will get R is voltage over current. Now let's say if you're looking to find the current of this circuit, you are going to need the resistance, and you can calculate the resistance by adding the resistance of each component. If the resistance here was 2 ohm and this was 3 ohm, then the resistance of the entire circuit will now be 5 ohm. And you can now find the current by using Ohm's law, whereby current is voltage over resistance. So 3 over 5 will give us the current of this circuit. And when asked to calculate the total resistance for a parallel circuit, the formula is a little bit different. You're going to take 1 over R total equal to 1 over 3 plus 1 over 3, giving us 1 over R total 2 over 3. But this is not our final answer. You have to remember to inverse this, so it's going to be 3 over 2. And if you are asked to calculate resistance when given a current voltage graph, you can get the resistance by looking at the gradient of the graph, because the gradient of the graph would be 1 over the resistance. Just remember that the steeper the gradient, the smaller the resistance. Next off, we've got electrical power, which is the transfer of electrical energy per second. So we can calculate power by multiplying current with the voltage. Remember, sometimes the current will be given in milliamperes. So to convert milliamperes into ampere, you're going to divide it by 1000. And next, we've got the equation for energy transferred, which can be calculated by I current, V voltage and time. And if you realize, IV is also the power, so energy can also be calculated by power times time. And next off, you've got potential dividers. When two resistors are arranged like this, it can be used as a potential divider. This may look complicated, but actually it is using the concept of ratio to split the total input voltage for the two resistors based on their resistance. So this will be the voltage in, and let's say this is the voltage out that we are looking for. So the voltage in would be 9 and the voltage out is what we're looking for. If we're looking for the voltage in, then we're going to put the total resistance of the whole circuit, which is 3 ohms, because we're adding them up together. And the V out, the resistance opposite to it is 1. So rearranging this, the V out is 3 voltage. Similarly, if you just try to understand this according to ratio, we're trying to split 9 voltage to both of these resistors in the ratio of 2 to 1. Since this has a higher resistance, it would get a higher voltage. This has a lower resistance, it would get a lower voltage. So in the ratio of 2 to 1, we split this into fraction and multiply the total. You would get 3 voltage and 6 voltage. So 6 voltage here and 3 voltage here. So you can look up the past year question, which I have linked at the top of this video, to look at an example for this type of question. And last part of this chapter is electromagnetic effects. Make sure you know what is a simple transformer, how it works. This is what it looks like. When you're given with a diagram of transformer, they're either asking you to calculate the number of turns of coil, the input-output voltage, or the current. If they want you to find the number of coil, then they will give you the primary and secondary voltage. And if they're asking you to find the secondary voltage, then they'll give you the number of turns for primary and secondary coil. And this works the same if they're asking you to calculate the current in primary and secondary coil. So you just have to use this formula. If you're being tested on power losses in cable, then there's another formula for power, which is P equals to I square resistance. If you don't know which formula to use in your exam questions, then always list down whatever information is given in the question. Let's say the question gives you current and the question gives you resistance, and then they want you to find power. So you can see that this formula over here consists of all the quantities that is being tested in the question. So this is why remembering formulas can be really helpful when you want to tackle and solve a calculation-based question. And next, moving on to chapter 5. Chapter 5 have no formulas that you have to memorize, but you will be tested on how to write nuclide notation, and there will be question that is related to half-life, which might need you to calculate, but no formulas. For nuclide notation, Let's say they mention in the question that uranium-230, and then you can get the proton number from your periodic table, decays to form another element with helium. So you should know that helium has the nuclear notation of 4-2, which is similar as alpha. Then to find what element is being released, you're going to look at its proton number. So the proton number adds up to give you 92, meaning that the proton number here is 90. And then as for the nucleon number, is the same. It has to add up to give you 230. So over here would be 226. And then you're going to look up your periodic table to see which element has the proton number of 90, and you're going to write your element. So what you should remember is alpha decay, which has 4 and 2 nuclide notation, beta is 0 and -1, and gamma has 0. And then as for half-life calculation, when you are given with the sample half-life or count rate per minute, the first step that you should always do is remove your background radiation. So let's say it's 120 count per minute and there's always 20 count per minute as your background. Remove this to get the counts per minute for your sample, and then half-life, meaning that it will reduce into half. Let's say the half-life given is 5 days. This means that 5 days represents your sample becoming half. So in another 5 days, your sample will become 20 counts per minute. So if they want to find out how many days does it take to reach from 100 to 10 counts per minute, then you can keep dividing. Sorry, this is 25. And I'll change this to 12.5. So keep dividing until you arrive this value. You've divided 1, 2, and 3 times. So it went through 3 half-life. Since each half-life is 5 days, that means the total is 15 days to arrive from 100 to 12.5 counts per minute. And if you are asked to give the readings on your Geiger molar or on the device, then you have to add back with your background radiation, which is 20 counts per minute. So after 15 days, the reading would be 32.5 counts per minute, because 12.5 is what happened after 3 half-life. Always don't forget to add back your background radiation. Okay, and the last chapter, you should know the formula for orbital speed, which is 2 pi r over t. The velocity here is how fast an object is orbiting another object. Let's say like the moon moving around the sun. And then the radius would be from the center of the sun to the center of the earth. In these types of question, the time could be anything depending on what the unit of speed is. Let's say if the speed is in kilometers per hour, then make sure your radius is in kilometer and your time has been converted into hours. If it's given, let's say in 365 days, then multiply it with 24 to change it to hours. And next, make sure you know the value for speed of light, which is 3 times 10 to the power of 8 meters per second. Let's say you are given with the distance of 2 objects and you want to find what is the time taken for the light to reach, let's say from the sun to earth. So the speed of the light is traveling at this value and the distance is 100 kilometers. Pay attention here that the speed of light is in meters. So you have to convert this also into meters, and that's how you're going to get your time. The distance over the speed of light. And for the second part of this chapter, you must know that 1 light year is equal to 9.5 times 10 to the power of 15 meters, and that Hubble constant can be calculated by recession velocity over distance. Recession velocity is how fast the galaxy is moving away from Earth, and the distance here is how far that galaxy is away from Earth. We can plot a graph for the distance versus recession velocity, and the gradient of this graph is what represents the Hubble constant, which is 2.2 times 10 to the power of -18 per second. And if we inverse the Hubble constant, which is recession velocity over distance, we can actually find the age of the universe. And this is the evidence that all the matter in the universe was present at a single point. Alright, so that's all the formulas and calculation and some important things that you should remember. If there are any formulas that I have missed out, please share it in the comment section below. And for those of you taking your exams on this upcoming Monday, I wish you best of luck. Thank you. Bye bye. Take care.